Hello everyone, welcome to another video of quantum mechanics. We'll be solving more PYQs of gate. Okay, so question number one. That'll be, I think, question number. We solved around 10 questions in the previous class. Anyway, question number one. The differential cross section d sigma by d omega for the central potential for the central potential Vr is equal to beta by r e to the one mu r. Okay, where beta and mu are constants. Okay, is calculated is calculated in the first Born approximation. Calculated in the first Born approximation. Its dependence its dependence on the scattering angle its dependence on the scattering angle theta is proportional to hash. Okay. Option A square plus sine square theta by 2. Option B a square plus sine square theta by 2 inverse. Option C a square plus sine square theta by 2 minus 2. Option D a square plus sine square theta by 2 square. Okay, this is the question. The differential cross section d sigma by d omega for the central potential Vr is equal to beta by r e to the power minus mu r. Central potential is given. Calculated in fast Born approximation. Its dependence on scattering angle theta. Okay, its dependence on scattering angle theta. So how to calculate this term? Let's see. So we know scattering amplitude f of theta is minus 2 mu by what? That's 2 mu by h square cube. Otherwise, you can just directly write f of theta proportional to 0 to infinity Vr sin qr Vr sin qr dr, isn't it? Right? Sin qr dr. And we know differential cross section, right? Differential cross section sigma is proportional to f of theta whole square, isn't it? F of theta whole square. Okay. Now, if we put the central potential in place of Vr, that will be f of theta proportional to 0 to infinity. What is the central potential we got in the question? Beta by r e to the power minus mu r sin qr dr. Okay, sin qr dr, and there is another r here. R V R, sorry, r. So this r will be cancelled. So f of theta proportional to beta 0 to infinity e to the minus mu r sin qr dr. Yeah, sin qr dr. Is that all right? Okay. So now how to solve this integration? How to solve this integration? We know sin qr is what? We know sin QR is e to the power IQR minus e to the minus IQR by 2y. So I'll just put it here. I'll just put it here. I can write equal to 0 to infinity minus mu r because IQR minus e to the minus IQR by 2y dr. Okay. So by 2y goes out. It doesn't matter. We need the proportionality only. So 0 to infinity the minus mu plus IQ r dr minus 0 to infinity e to the power minus mu minus IQ r dr. Okay. So leave beta by 2i. So it will be e to the minus mu plus IR r divided by minus mu plus IR 0 to infinity minus e to the minus mu minus IQ r divided by minus mu minus IQ 0 to infinity. Okay, now infinity we can put in place of r, right? So if you do all that, our this one will come as mu plus, we can have the LCM, otherwise let's do one thing, 1 by minus mu plus IR plus 1 by mu plus IR, sorry mu IQ, sorry, this is IQ, sorry, IQ, IQ, okay. So that will be minus mu plus IQ, so mu plus IQ, 0 mu plus IQ minus, so plus minus mu plus IQ. Yeah, mu will be cancelled out. So 2IQ divided by what is in the middle side? Q square minus mu square, isn't it? So minus, just take it out. 2IQ by mu square plus q square. Yeah. So this is the what? This is f of theta proportional to. So f of theta is proportional to mu square plus q square to the power minus 1. So our differential cross section d theta, suppose sigma theta, proportional to what? F of theta square. So that will be mu square plus q square minus 2. Right? Either mu square plus q square minus 2, where we know q is equal to what? Q proportional to what? Sin theta by 2. Isn't it? Q is sin theta by 2. So I can just write sigma theta is proportional to mu square plus sin square theta by 2 minus 2. Okay. So this would be your dependence. If you see the options, mu suppose a. So a square plus, as we have got sin square theta by 2 over minus 2. See which option? Option C. Right. Is that all right? Is it all right? Yeah. So first of all, we need to know if theta scattering amplitude RBR sin QR dr. Then your cross section is your square of amplitude, scattering amplitude. Okay. So I just took the square here and took the integration there inside and did the integration. I divided sin QR. I can write it as, because we know sin theta can be written as e to the I theta minus e to the minus I theta by 2i. Okay. So just write it here. This. Okay. Okay. Next question. Question number 2. The nth energy eigenvalues. The nth energy eigenvalues En of a 1D Hamiltonian, which is equal to p square by lambda m, p square by 2m plus lambda x4. Okay, lambda x4 in the WKB approximation is proportional to option n plus half 4 by 3 number to the 1 by 3 n plus half 4 by 3 number to the 2 by 3 n plus half 4, 5 by 3 number to the power 1 by 3 n plus half 5 by 3 number to the power 2 by 3. Do this question, very easy one. Nth energy value of eigenvalue. Just do it, try. We have done this type of question in the previous session also. So try it first. Okay, see. See, this question is related to WKB approximation. So if you remember the WKB approximation, the shortcut for the formula is En proportional to n to the power 2m by n plus 2, whereas m is the power. But here lambda is also asked, the power of lambda. So the whole formula is in En is equal to alpha. En is equal to alpha n minus half h cut root over of pi by 2m alpha gamma 1 by m plus 3 by 2 by gamma 1 by m plus 1 divided to the power 2m plus 2m by m plus 2. Okay. En is equal to alpha n minus half h cut. It can be n plus half also, no problem. Okay. According to you, just see that. If n starts from 1, 2, 3, 4, this formula is right. H cut root over of pi by 2m alpha. Okay, this alpha is the one that is given in the question. Question is what? What is the question? Question is h is equal to p square by 2m is lambda x4. So this lambda is your lambda. The lambda is your alpha. This x4. 4 is your m, small m. This is mass. This is 1. So let's put it lambda n minus half h cut root over of pi 2m lambda. The gamma 1 by m is how much? 1 by 4 plus 3 by 2 gamma 1 by 4 plus 1. We don't need these values, we just need the dependence, right? 2 into 4 by 4 plus 2. So lambda, and here the lambda power is half, right? Minus half into lambda minus half, and whatever there is inside n, suppose n, the whole thing is n. We don't need all this. 8 by 6. Okay, 8 by 6. So lambda half n to the power 4 by 3. That is the answer. N plus half. N plus half to the power 4 by 3. This is it can be n plus half also if it's n starts from 0. Okay, that's the answer. So this option. Okay, my bad. Wait, see here lambda. Here lambda is minus 1 by 2, but there is also this one, right? Lambda minus 1 by 2 n plus half to the power 4 by 3. So that will be also counted. I made a mistake there. Lambda into lambda minus half into 4 by 3, then n plus half to the power 4 by 3. My bad. So lambda into this is how much? 2 to cancel, minus 2 by 3. So 1 minus 2 by 3 into n plus half to the power 4 by 3. So lambda 1 by 3 n plus half 4 by 3. Is that alright? That is the answer. Yeah, that is the answer for this question. I hope you understood. WKB approximation here an easy question, so I hope we should be able to solve this question easily. Next question, question number 3. Particle of mass m is confined in a three-dimensional box by the potential Vxyz is equal to 0, 0, less than x, y, z less than equal to a, and infinity otherwise. This is a three-dimensional symmetric potential. Okay. The number of eigenstates of Hamiltonian with energy 9 pi square h cut square 2 m square is. Number of eigenstates of Hamiltonian with energy 9 pi square h cut square by 2 m square is 1, 6, 3, 4. Okay, right. Very easy question again. Very easy question. So you try. Okay. You see, I hope you could solve it. Potential is given. So this is a three-dimensional symmetric potential. So energy eigenvalue is what? Hmm? Pi square h cut square by 2 ms square nx square plus ny square plus nz square. What is the question? Number of eigenvalue Hamilton with energy 9. So how can I get this value as 9? How many times can I get 9? How can I get it? If I write 3 square plus 0 square plus 0 square is 9. Hmm. That means 300, okay, 300, 030, But the thing is, this is a three-dimensional box, and in boxes, 1D box, 3D box, 2D box, anything, the ground state starts from 1. Okay, the ground state starts from 1, not 0. This is not possible. If it was an harmonic oscillator, we could have thought about it, but harmonic oscillator, eventually the energy would have been different. But here, the thing is, it cannot start with 0. Okay, so for 9, so we can have it like 2 square plus 2 square plus 1 square. This is the only configuration, like 4 plus 4 plus 1, that is 9. So 2 2 1, 2 1 2, 1 2 2. So 3 eigenstates. Yeah. So what? Number of eigenstates is 3. Option C. Answer is 3. Easy question. Easy question. Yeah. Easy question. Great. Next question. Question number 4 now. Particular mass m is constrained to move in a circular ring. Move in a circular ring of radius r. When a perturbation v dash is equal to a by r square cos square phi is added, the shift in energy of the ground state, the ground state to first order in A is option A by r square, option B 2a by r square, option C a by 2r square, option D a by pi r square. Particular mass m is constrained to move in a circular ring of radius r. When a perturbation v dash is equal to a by r square cos square phi is added, the shift in energy of the ground state to first order in A is dash. Try this question. Take your time, try this question. If you don't try, then there is no point. If you just copy my answers, then Okay, so perturbation is given V dash is equal to A by R square cos square phi. So what is asked? Shift in energy, right? Shift in energy. So, okay, shift in energy in the ground state. All right. So we can, what can we do here? So V dash, we can take V dash, expectation value of V dash, right? Expectation value of V dash. This is a circular orbit. Hmm. Circular ring. So the limit, if we take the integration, the limit will be from 0 to 2 pi, isn't it? 0 to 2 pi. So let's do it. Integration. Um, what should we? Cos square phi. Okay. Here we can say phi naught should be 1 by root over 2 pi. Okay. So this can be written as this. Yeah. So we can write it as 0 to 2 pi 1 by root 2 pi a by r square cos square phi by root over 2 pi d phi. Yeah. So 1 by 2 pi goes out, a goes out, r square goes out. So 0 to 2 pi cos square phi I can write it as 1 by cos 2 phi by 2. Yeah, d phi. Isn't it right? So a by 4 pi r square. Now integration is phi plus sine 2 phi by 2, 0 to 2 pi. Yeah. So a by 4 pi r square 2 pi plus sine 4 pi is 0, isn't it? And this is only 2 pi then because 0 is 0. So 2 pi cancelled out 2. So a by 2 r square. This is the answer. This is shift in energy, okay? En1, whatever. Ground state energy, so E01. A by 2 r square. So let's see the options. A by 2 r square. Is that alright? Do another question. First question number 4. Question number 5. Consider a one-dimensional infinite square well. One-dimensional infinite square well. Vx is equal to 0 to infinity. 0 infinity. This is for 0 less than x less than a. 0 less than x less than a. Infinity otherwise. Okay. If a perturbation, if a perturbation del Vx is equal to V naught for 0 less than x less than a by 3, 0 otherwise. Okay, is applied. Is applied. Then the correction to the energy, then the correction to the energy of the first excited state. first excited state to first order in del V is nearest to dash. Option A V naught, option B 0.16 V naught, option C 0.2 V naught, option D 0.33 V naught. Try this question. Okay. Consider a 1D infinite square well Vx is equal to 0 infinity. Perturbation del Vx is V0, V0, 0 otherwise applied. Then the correction to the energy of the first excited state to first order in del V is nearest to. Okay. Hands question. First excited state. This is a 1D infinite square well. Okay. So the wave function can be written as what? As is the excited state sine 2 pi x by n is equal to 2. Yeah. So the perturbation is V naught. So if we calculate the expectation value of V dash, that will be 0 to what? Up to what the perturbation is there? 0 to a by 3. Okay. So the limit will be 0 to a by 3 root over of 2 by a sine 2 pi x by a V naught root over of 2 by a sine 2 pi x by a dx. So V naught into 2 by a 0 to a by 3 sine square 2 pi x by a dx. Okay, so 2v naught by 3a. So 1 plus sine square 2 pi x by a I can write as 1 minus cos 4 pi x by a whole divided by 2 integration 0 to a by 3 dx. So 1 by 2 goes out. V naught by a integration 0 to a by 3 1 minus cos 4 pi x by a dx. So v naught by a, now this one is integration x minus sine 4 pi x by a whole divided by 4 pi by a 0 to a by 3. Yeah. So now put a by 3. So that will be a by 3 minus sine 4 pi by a into a by 3 divided by 4 pi by a, and this will be 0 0. Alright. So now v naught by a, so a by 3 minus, this is a cancel, sine 4 pi by 3 is how much? Sine 4 pi by 3, that means sine 240 degree. That means what it comes in third quadrant, and like 180 plus 60, right? So it will be minus sine 60, that will be minus root 3 by 2 divided by 4 pi by a. Okay, so v naught by a by 3 minus a by 4 pi, this becomes plus root 3 by 2. So a goes out, a got cancelled, 1 by 3 plus root 3 by 8 pi. Okay, this will be the answer, root 3 by 8 pi. So if you calculate it, you will get it as 0.33 V naught. Okay, see, so easy it is. It's very easy. Yeah. Okay. Clear this question. Let's move to the next question. So, this is your question number 5. Write down a phase shift of 30 degree is observed when a beam of particles energy 0.1 MeV is scattered by a target. Okay. When the beam energy is changed, okay, the observed phase shift is 60 degree. Assuming that only S wave scattering assuming that only S wave scattering assuming that only S wave scattering is relevant, and that that the cross section does not change with energy, the beam energy is Its phase shift of 30 degree is observed when a beam of particles of energy 0.1 MeV is scattered by a target. When the beam energy is changed, the observed phase shift is 60 degree. Assuming that only A sweep scattering is relevant and the cross section does not change with energy, the beam energy is. Cross section doesn't change with energy, the beam energy is. Okay, so we know cross section formula sigma is equal to 4 pi by k square summation I 0 to infinity 2i plus 1 sine square delta. Yeah, sine square delta I. Is that all right? For okay, so only A wave scattering is relevant. A wave scattering is relevant. Only A wave scattering is relevant. So for A wave, we know for A wave I is equal to 0. Huh? Yeah, and we know K is equal to what? 2 me by h cut square root over. Yeah. So sigma will be what? Sigma will be 4 pi by k square. This will be 0. I will be 0 sine square delta 0. Yeah. Now 4 pi by k square in place of k, just put this 2 me by h cut square. Put it sine square delta 0. Yeah. So it becomes 4 pi h cut square by 2 me sine square delta 0. Is it alright? Yeah. So this is your cross section. What is the question? Cross section doesn't change with energy, the beam energy is. The observed phase shift is 60 degree. Hmm. Assuming that only S wave is different. Okay, first of all, the phase shift was 30 degree and the energy was 0.1 MeV. Yeah, and now phase shift is 60 degree and the energy is asked. So we can see initial cross section is equal to final cross section. We can say that. So sine square 30 degree divided by, we'll just take the ratio E1. Okay, E1 is 0.1 MeV is equal to sine square 60 degree. Sorry, did I do mistake? First it was 30, yeah. Sine square 60 degree divided by what is asked, energy is asked, E. Okay, so this is what we have to do. Sine square, that is 1 by 4 divided by 0.1 is equal to 3 by 4 divided by E. 4 got cancelled. So E is equal to 0.3 mega electron volt. E is equal to 0.3 mega electron volt. Alright, that's the answer. Again, just remember, you have to remember sigma is equal to 4 pi by k square summation I, can small I to capital A, anything you can use, 2i plus 1 sine square delta I. So here for A wave, we know A wave I is equal to 0. So just put it sigma 4 pi by k square what? Sine square del I del 0. This is for your S wave. But the thing is k is, we know 2 by h square because we need E, right? So we have to put E. We cannot do anything with k. So we have to put E. So I put E here and I took the ratio, I equated them, and this is what I got. Alright, clear? Okay, this was your question number 6. Question number 7. Question number 7. The normalized wave function. The normalized wave function in the momentum space of a particle particle in one dimension is phi p is equal to alpha by p square plus beta square. The uncertainty del x, the uncertainty del x in measuring its position is yes. Option A root over pi squared alpha by beta square. Option B root pi h squared alpha by beta cube. Option C h squared by root 2 beta. Option D root over of pi by beta h squared alpha by beta. This is what it is. Normalized wave function in the momentum space of a particle in 1D is phi p is equal to this much. The uncertainty del x in measuring its position is yeah. Try this question. Okay. So we know del x is what square minus del x square. So we know del x is should be 0. Expectation value of this one will be 0. So like okay. So here momentum in momentum space the this one is given phi p is equal to alpha by p square plus beta square. Okay. So like if we convert into a real one like the position space it will be psi x is equal to beta by h squared e to the power minus beta x by h. Okay, yeah. So we just have to take the expectation value of x will be 0. Expectation value of x square we have to find out. Okay, how it will be 0 to infinity, sorry minus infinity to infinity beta by h squared x square e to the power minus 2 beta x by h squared dx. Okay, so beta by h squared, hmm, beta by h squared, and this whole integration will be what h squared by 2 beta cube. Okay, this will be the one. So this one will be sorry, the whole integration will be h squared square by 2 beta square. That will be the integration. Okay, if you calculate it. So if we just put it here, del x is equal to that will be root over of h square by 2 beta square. That is h squared by root 2 beta. Question number 8. State vector of a one-dimensional simple harmonic oscillator simple harmonic oscillator of angular frequency omega at time t is equal to 0 is given by psi 0 is equal to 1 by root 2 0 plus 2, where 0 and 2 are the normalized ground state and second excited state respectively. The minimum time t after which the the state vector psi t is orthogonal to psi 0 is. State vector of a 1D simple harmonic oscillator of angular frequency omega t is given by this. A normalized ground state this. Minimum time t after which the state vector is orthogonal to psi 0 is option A pi by 2 omega, option B 2 pi by omega, option C pi by omega, option D 4 pi by omega. Okay, try this question. See, state vector of 1D simple harmonic is given by this. After time t, psi t will be orthogonal to psi 0. That is what you are asked. So we know psi 0 is given as 1 by root 2, 0 plus 2. This one is given. Hmm. Right. So if you see, this is a what? Harmonic oscillator. Right. Now psi t will be what? Just t terms will be 1 by root 2, 0 e to the power minus I would be the one minus IE t by h cut IE 0 t by h cut plus 2 into the minus I 2 t by h cut, isn't it? What is E0? E0 is h cut omega by 2. E2 is what? 5 h cut omega by 2. Right? So we'll put it here. So 1 by root 2, 0 e to the power minus I h cut omega by 2 t by 2 h cut omega h cut plus 2 e minus I 5 h cut omega t by 2 h cut gone, h cut cancelled out. So 1 by root 2, 0 e to the power minus I omega t by 2 plus 2 e to the power minus 5 I omega t by 2. Yeah, is that all right? Now after time t they will be orthogonal. That means orthogonal means psi 0, psi t will be, their inner product should be 0, isn't it? Okay, got it? Hmm? That means what? That means 1 by root 2, 0 plus 2, that will be 1 by root 2, 0 e to the power minus I omega t by 2 plus 2 e to the power minus 5 I omega t by 2. Yeah, is equal to 0. So 1 by 2 into e to the minus I omega t by 2 plus e to the minus 5 I omega t by 2 is equal to 0, isn't it? Right. So e to the power minus I omega by 2 plus e to the power minus 5 I omega by 2 is equal to 0. Okay, so e to the power minus I omega t by 2 is equal to minus e to the power minus 5 I omega by t by 2. So if I take it to this side, it will be e to the power 5 I omega t by 2 minus I omega t by 2 is equal to minus 1. Yeah, that will be e to the power, this should be 2 I omega t is equal to minus 1. Okay, so we know e to the power I 2 I omega t. E to the power minus 1 is e to the power I pi, right? I pi. So 2 I omega t is equal to I pi. So I cancelled. So t is equal to how much? Pi by 2 omega. Is it clear? Is it clear? I did every step. I didn't even leave one step so that you can understand. I hope it is clear. I hope it's clear to you. I hope it's clear to you. Just see once if you don't understand, let me know in the comments. Okay, clear? Next question, we'll move to the next question. This is your question number 8. Question number 9. The normalized wave function of a particle in 3 dimensions is given by psi r theta phi is equal to 1 by root over of 8 pi aq e to the minus r by 2a. Okay, where a greater than 0 is a constant. The ratio of the most probable distance from the origin to the mean distance from the origin is the ratio of the most probable distance from the origin to the mean distance from the origin. The normalized wave function of a particle in 3D is this. The ratio of the most probable distance from the origin to the mean distance from the origin. Okay? Yeah? Normalized wave function of a particle in 3 dimensions is given by this. Okay. The ratio of the most probable distance from the origin to the mean distance from the origin. That is what you are asked here in this question. How to solve it? See, I will write the solution. Psi r theta phi. Here is how much? 1 by root over of 8 pi a cube e to the minus r by 2a. Right? R is what? R is R can the expectation value of R that will be how much? Triple integration I R psi star R psi r square dr, okay, sin theta d theta t 500. Okay, so this can be what? This will be this can be calculated to be 3 by 2 into 2a. That will be, if we just put the values here, that will be 3a. Okay, so uh, so the most probable distance will be what? Most probable distance. This is the mean distance. Most probable distance will be d by dr of whatever that is given in the way, like no, it's not given, na? Yeah. Most probable distance is d by dr of r square e to the minus r by a. Okay, we would have studied in hydrogen atom. Yeah. So 2r e to the minus r by a plus minus 1 by a r square e to the minus r by a. Yeah, 0. So e to the minus r by a goes to that side. So 2r minus r square by a is equal to 0. So 2r is equal to r square by a. So r is equal to 2a. So most probable distances are 2a. So r most probable by r mean will be what? 2a by 3a. That is 2 is 3. Okay. Yeah. Yeah. Okay. Next question. Question number 10. Question number 10. Let x denote the position operator and P the canonically conjugate momentum operator of a particle. Okay. The commutator 1 by 2m p square plus beta x square minus p square by m plus gamma x square, okay, is 0 f. Okay. Option A, gamma is equal to b beta. Option B, gamma is equal to 2 beta. Option C, gamma is equal to root 2 beta. Option D, 2 gamma is equal to beta. Okay. It takes the position operator, P the canonically conjugate momentum operator of a particle. The commutator this is 0f. Answer. So P square by 2m plus beta x square. P square by 2m is gamma square. Okay, is 0. It's given as 0. So let's do it. P square by 2m comma p square by 2m is gamma x square plus beta x square p square by 2m is gamma x square. So these two will come in. So we can write p square by 2m will be going with this, and beta x square will be going with this 0. So this is gamma by 2m p square x square plus beta by 2m x square p square. Is that right? Okay. So gamma by 2m I can write as minus of x square p square is beta by 2m x square p square. Yeah, x square p square I just can take to that side. So the minus gamma by 2m plus beta by 2m is equal to 0. Gamma is equal to beta. Okay, is that alright? Did you do any mistake? Okay, this is by m na. I need it to m. No problem. This is only m. So only m will come out. M. So this is m. Okay, then minus gamma by 2m is equal to minus beta by m. M gone, minus minus gone, so gamma is equal to 2 beta. And that is the answer. Gamma is equal to 2 beta. I hope you understood, and I hope you understood the concepts we discussed in the class. These are some of the previous year questions we did. I hope, and like almost we have covered all the concepts in this video. And I hope you can solve the questions in yourself. And any doubt, please let me know in comments. Thank you very much.